Hi everyone, in this lab I'm going to talk about Eigrp path selection. This is the second video of the Eigrp path selection. You should watch the path selection Eigrp part 1 as well. So in this lab what we are going to do is per destination path selection using the offset list. So from router 1 to get to these destinations, right now we will see that we are going via both the routers, via router 3 and via router 2. The IP addresses are configured as well as the Eigrp configuration is already done. Okay, so on router 1, when we do show IP route for 7110 subnet, we can see that we can go via router 3 and we can go via router 2. The share count is equal, one packet from one link each. Likewise, for the second subnet, we have two paths installed in the routing table. For subnet 4, we have two paths installed, and for subnet 5, we have two paths installed. So what we want to do is, in the lab 1, we want above two networks, 7110 and 20. It should go via router 1 to router 3, then to router 4, router 5, then router 7. This is what we want to achieve in this lab 1, just these two prefixes or subnets. In the lab 2, we want to achieve these two subnets, 714050. They should go via router 1, router 2, router 3, router 6, and then router 7. Let's do this practical. So before starting with the lab 1, okay, we need to check on router 4 how these two prefixes are being learned. Let's go to router 4 and check show IP route for 7110. Okay, so we are choosing two paths to get to destination 7110, and when we do show IP Eigrp topology for 70 prefix /24, and over here as well we can see we have two successors for this destination. So what we have to do is, for this lab, for networks 10 and 20, we want to go via router 5. Okay, so what we have to do is, why these two paths are installed in the routing table to begin with, because we have the same feasible distance as well as the advertised distance via router 5 as well as via router 6. Okay, so we want to select router 5 in this case, not router 6. So what we are going to do is, we are going to add just 5 metric to this feasible distance, so it will become 435205. So once this feasible distance goes higher, this will go away from the routing table. It will not show up, only this path will show up. Let's check this out. What we have to do, first of all, we have to create an access list. Before that, let's verify what access list do we have already in the running config. None. Now access list 1 permit and the second prefix is going to be our second network on router 4. Now under the Eigrp config, use offset list. Now define your access list which we just have created, and the updates which are being received on Ethernet 0/2. Okay, incoming updates, we are going to add metric 5 on the updates we are receiving on interface Ethernet 0/2. Okay, and likewise we are going to create one more access list, second, for subnet 71.4.0, and access list 2 permit subnet 5.0. Under the Eigrp config, offset list, now this is gonna be the access list 2. These are also incoming updates. Okay, uh, we are going to add metric 5 on the interface Ethernet 0/3. Okay, so before I execute this command, I'm just going to hold this command. So this command is not executed by putting the exclamatory sign over there. I'm gonna show you show IP route for 71.1.4.0. So we have both the paths in the routing table right now via 46 and 45. So for this 71.4, I'm also doing the lab 2 side by side. So for the 4 and the 5, we wanna prefer router 6. Okay, so in this case we wanna prefer router 6, so we are going to add metric 5 for the updates which we are receiving on interface Ethernet 0/3. Okay, do show IP Eigrp topology for 71.4.0/24. So in this case we can see that feasible distance AD values both are similar. That's why both the routes are installed in the routing table. Now I'm going to execute this command, which says calling the access list second, the updates we are receiving on interface inside Ethernet 0/3 via router 5, and we are adding metric 5. These are executed. I'm gonna do show clear IP Eigrp neighbors. To clear IP Eigrp neighbors. Well, before that we can also see a message popping up on the screen. The topology has been synchronized already after putting these two offset list commands. Now check the topology for subnet 4. Okay, so we can see that feasible distance has been increased for the subnet 71.4.0 via 45.0.0.5. So above feasible distance via router 6 is still the same value, 435,200, and below 435,205. So now when we check the routing table for 71.4.0, we should be having just router 6 in the routing table. So via router 6 we are going to 71.4.0 network. Likewise for 71.5.0 we are going via router 6. Okay, so when we check via for router for network 71.0, we are going via router 5, and for the second 71.2 network we are also going via router 5. So this part is done on router 4, and when we check the access list we can see the matches are there, which means the access list is working. Now let's go to router 1 and check show IP route for 1. Okay, the second access list is gonna add over here. What we want to do is create an access list. Before that, let's verify if we have any access list in the config. Access list 1 permit 71.0. Second network, create access list 2, define other 2 networks, and the last network 71.5.0 under the Eigrp config. Okay, before that I want to show you the topology table for this. Okay, so we have both the successors. We have 2 successors via router 2 and router 3. So offset list, call the lab 1 networks, and we want to prefer these 2 networks via router 3. So we are adding metric 5 for the updates which are received on Ethernet 0/1. Okay, 5 Ethernet 0/1, and for the access list 2 we are adding metric 5 over the interface Ethernet 0/2. The topology has been synced. Check the topology table. For prefix 70110, we can see now we have just one successor and we are going via router 3. For the subnet 71.2, we have just one successor and we are going via router 3. For the other two networks which are in the lab 2 are 71.4, we are going via router 2 in this case. Okay, and for the last network 71, we are also going via router 2. So now when we do a trace from router 1 for 71, okay, you can see the first hop is 13.003, second is 34.004, the third hop is 45.005 router 5, and the last hop is 57.007. So this is what we wanted. Okay, router 1 to router 3 to router 4, router 5, then to router 7. And for the next lab, for the network 7140 or 50, we wanted to go via router 1 to router 2, 12.002 first hop, and second hop is 24.004, which is router 4. Third hop is 46.006, which is router 6, and the last hop is router 7, 67.007. I'm gonna paste this configuration in the video description. You can check it out. Thanks for watching.